Did you have pancakes this morning? So the title of today's lesson is Right Triangle Trigonometry. And you might be thinking to yourself, isn't that what we've been doing this whole time? And you're correct. We have been dealing with trigonometry. We've been dealing with right triangles to figure out our different values of trig functions in the unit circle and our trig chart. But keep in mind that with each one of these lessons, we're just going to have a few little concepts that we're adding to it. The whole idea is that by the end of this, you'll have learned a lot of trig by only getting a little bit at a time. So at the end, you're like, oh, trig is easy. I've got this. In our first example, we're trying to figure out all 6 trig functions for theta. And then we're told that the tangent of theta is 2/3. I think the weirdest part of this type of question is that I think our minds go to what is theta, but we don't necessarily need to know the angle in order to figure out the other 6 trig functions. Just by knowing that tangent of theta is this 2/3, I can figure out my sine and cosine from those and then take the reciprocals to find the other 3 trig functions. So because I know that the tangent of theta is 2/3, what it's really telling me is that if I have a right triangle, and we could put theta wherever we want, it's just gonna look like a blob. But if I have the tangent of theta is 2/3, that means my opposite over adjacent is 2 and 3. Now, this is simplified, so it could be that these sides are actually like 4 and 6. That would still be the same ratio, 2/3. But when I go to find my hypotenuse, it's not going to matter if I have 2 and 3 or if I have 4 and 6, because they're going to be in the correct ratio for the hypotenuse as well. So you might have had that thought. So from here, if I'm going to find my sine and my cosine, I need that hypotenuse. So I'm going to go ahead and use Pythagorean theorem to solve for my missing side. So I'm going to get my 4 plus 9. And we get that that side that's missing is a radical 13. Okay. Which means I'm going to have some simplifying to do when it comes to my sine and cosine, because that's going to be the denominator. So for sine of theta, I've got my opposite over hypotenuse, so 2 over radical 13. And then simplifying, multiplying by radical 13 over radical 13, I'm going to get 2 radical 13 over 13. Cosine is going to be really similar. I've got my adjacent over hypotenuse, so I've got 3 over radical 13. And kind of as we notice some patterns here, I know that if I multiply top and bottom by radical 13, I'm going to get a 3 radical 13 over 13. So I can make that jump, but you definitely want to see that first step, so don't jump too far. Tangent we already had, so there's really not a point in rewriting it unless you just want to. For cosecant, I've got the reciprocal of sine, and I want to back up to that original sine before I simplified it, because now if I take the reciprocal of this original, my radical is in the numerator, not the denominator, so I don't have to simplify it. So my cosecant is just going to be radical 13 over 2 from taking that reciprocal. Let's see, sorry, secant. Ignore that. Okay, so now secant. Same thing with cosine. I don't want to go to that simplified because the reciprocal is going to need to be simplified, but if I take the reciprocal of that original, I'm going to get my radical 13 over 3. And then my last one for cotangent, I'm going back to what I was originally told, that tangent was 2/3, so that means that my cotangent is going to be 3/2. So there we have it. Those are all of our 6 trig functions if tangent of theta is 2/3. So example 2 is actually easier than example 1 because they went ahead and gave us this triangle. So for the first one, we had to set up our triangle. For the second one, they just give us the triangle. And your homework has a handful of these where we're just trying to use the sides that we're given. We are going to have to find that third side, and then finding our 6 trig functions from there. The directions are the same on this one. So go ahead and pause the video, see if you can find all 6 trig functions on your own. After using Pythagorean theorem, we can roll through each of our trig functions here, just finding the ratio that corresponds. Our sine is going to be 6/10. All of these are going to be able to simplify because they all are even numbers. So we've got 3/5. Our cosine of theta is going to be adjacent over hypotenuse, so 8/10, which is 4/5. Our tangent is going to be 6/8, or 3/4. Cotangent, oh, I left out my theta there, didn't I? My cotangent is going to be the reciprocal, so 4/3. My cosecant is going to be 5/3, and my secant is 5/4. Notice that I didn't have to go back to the original and say that cotangent was 8/6 and then simplify it. I used the simplified version. So you just kind of have to be smart about it, because with example 1, we actually wanted the original, and that was easier to take the reciprocal. Sometimes the simplified is easier to take the reciprocal. So for our last 3 examples, we're going to do something a little different. Instead of figuring out the ratios for the different trig functions, for these we're actually going to try to figure out the angle that's giving us that ratio for whatever trig function we're talking about. Important thing to note here, we're going to be giving our answers in degrees and radians, so we'll have 2 answers for each one. And then we're noticing this domain that they give us, that for our degrees and our radians, these are both wanting the angle in the first quadrant. So we're not concerned with it being anywhere else in the unit circle, only whatever angle would be there in the first quadrant. Something else that we want to note here is that if this number is not something that is straight from the unit circle, then we would have to use our calculators for this. But these are all going to be ones that are from the unit circle, so we should be able to reason our way through this and figure out what theta is. And it's going to be one of those angles from the first quadrant of the unit circle. So starting with our example 3, if cosecant of theta equals 2, this is not necessarily one that I would have you memorize, but we can relate it to one that you have memorized. So we're going to go ahead and say that cosecant is actually the reciprocal of sine. So if cosecant of theta is 2, that means that the sine of theta is 1/2. So then I just have to figure out, or know, that if sine of theta is 1/2, sorry, I'm having trouble with my camera focusing. If sine of theta is 1/2 in the first quadrant, that happens at 30 degrees. So my theta is going to be 30 degrees, or pi/6 radians. Those are my 2 answers. Again, really important that we have those memorized from the first quadrant. At this point, if you still don't have them memorized, gotta go back and practice those. Make yourself some flashcards or something. For example 4, similar in the beginning here, that since I have cotangent and that's not really one I have memorized, I'm first going to go ahead and change it to tangent. And then since my tangent is the reciprocal of cotangent, when I flip my 1, I'm still going to have 1 as the reciprocal. Again, this really isn't one that I have memorized, so I kind of want to go through what sine and cosine would give me a tangent of 1. And in order for us to get 1 when we divide them, they would have to be the same. So if tangent is 1, we're talking about a situation where sine is that radical 2/2, and cosine is also that radical 2/2. So we would have to know, okay, when sine and cosine are the same, that happens when theta is 45 degrees, or pi/4 radians. And then our last one, our secant of theta equals radical 1/2. Again, going to change it to cosine first, because it is the reciprocal of secant. I'm going to get that 1 over radical 2. And then I do want to go ahead and simplify, but I can kind of see where this is going, that I'm going to get radical 2 over 2. And then I know that when cosine is radical 2 over 2, that happens when, and we already had it up here, when our theta is 45 degrees or pi over 4. So there's one more example that I want to go over because this is a type that students struggle with a little bit, just because it takes a little bit of trial and error and it doesn't come straight from something you have memorized, but rather using something that you have memorized. So if the tangent of theta equals radical 3, my first thought with this is that my sine and my cosine had to have involved radical 3 over 2 and 1/2. Because we know what happens with tangent when our sine and cosine are at 45 degrees, they're both radical 2 over 2, and we know at 0 degrees or 90 degrees that we're going to end up with like a 0 or an undefined or 1, something like that. But in order for us to end up with that radical 3 or a radical 3 over 3, it has to involve the radical 3 over 2 and the 1/2. So really all I'm trying to figure out, and this is where the trial and error comes in, is am I talking about when sine is radical 3 over 2 and cosine's 1/2, or vice versa? So I'm going to go ahead and just try both and see what happens. So if I look at sine of theta equaling radical 3 over 2 and cosine equaling 1/2, I'm just going to go ahead and see what happens to tangent. I would be taking my radical 3 over 2 and then dividing by 1/2, so flipping it and multiplying, and I am going to end up with radical 3. Okay, so this one actually worked. It worked the first time, but if it didn't work that time, then you would go ahead and try the other. So if I had sine of theta equaling 1/2 and cosine equaling radical 3 over 2, and this just doesn't take very long to go through and see whether it works or not, whether we're going to get radical 3. So same thing, going to flip and multiply. And we can see with this one that we're going to end up with that 1 over radical 3, which is really our radical 3 over 3. So this one's not the one that works for this, but we can try them both and see which one matches. From here, I just have to have memorized the sine and cosine in this first quadrant. So I need to know when sine of theta is radical 3 over 2 and cosine is 1/2. So as long as I know that in order for this to happen, I have to be at 60 degrees, which is pi over 3 in radians. So a little bit of extra work just on the trial and error piece of this. You can memorize this if you want to, but it's just not something that I have room in my brain for, to be honest. I trial and error it every time because it just takes a few seconds to think through, okay, if I were to flip and multiply by that cosine, would I end up with radical 3 or not?